Okay, so we're just trying to add wires to this. So that that output pin on the Arduino, uh, when that is high at 5 volts, um, the motor is on. And when you set that output pin low to 0 volts compared to the ground, the motor turns off. And so we have to go from the output pin that we're going to use to power it. We have to go from that to the base of the, well, we have to go through the resistor. So always remember that resistor in there. But then it's going to go from the resistor. That's already in the same row as the base of the transistor. So it's going through the resistor to the base. And then we're going from the emitter of the transistor to the ground. So the way that works now is when your program sets the output to 5 volts, a small amount of current flows from here through the transistor here, and that connects any circuit that goes through the collector and the emitter. So now we can use the collector and emitter to wire up this stuff. Okay, so I'm going to go from the battery positive side over here to the breadboard. And I'm going to go, I'm going to connect the positive of the motor to that same spot. So we're building up a setup where current is going to go from the positive of the battery through the motor and then to the negative of the battery. And so now it's going to go from here to, I'll choose another line. And then I'm going to connect that to the negative of the battery. And one thing we still have to do is we have to put this diode to be in the opposite direction of current through the motor. So I'm going to go the positive side of the diode to the negative side of the battery. I mean, negative side of the motor. So I'll go there. And then I'll go negative side of the positive side of the diode to the, hold on a sec. I have that going the wrong direction. Okay, so we only want current to be able to flow through the diode from the negative of the motor towards the positive of the motor. So I'm going to go, this side is going to go to the negative of the motor. This side is going to go through the positive of the motor. And then the last thing we have to do is connect the negative of the battery to the ground of the board. Those have to be at the same electric potential. So I'll just take I'll go from the negative of the battery. Is that right? Yeah, negative of the battery. To the ground, and I can connect to the ground right here. Anybody have any questions about that thought process? Yeah.
The diode allows the motor to.
It's so when you turn off the motor, you don't get an electrical surge that damages the sensitive stuff. The sensitive stuff is mostly the Arduino board.
And the positive and negative end of the diode go in between which.
So think of the diode as only allowing current from the like think of this as the tip of an arrow or whatever.
Okay.
So it only allows current that way.
Okay.
So so you want to put the tail side of so you only want current to be allowed from the negative towards the positive of the motor.
Okay.
So we'll connect this side to the negative of the motor and this side to the positive of the motor.
Okay.
Any other questions? I know it doesn't make any sense to just look at it. It's kind of too many wires, but thinking through the thought process, hopefully that sort of makes sense.
Am I looking at this wrong, or is there nothing attached to the emitter? Or the collector, rather?
Oh, yeah.
Oh, yeah. That's important. So we got to go through the motor because I have all my stuff connected. That motor is not doing anything right now. So we're going from the negative. I just put it in. I just connected it to the. Whoops. So this should have gone. From the negative of the motor to the collector. And now let me think about it. So negative of the motor to the collector and then out the emitter. And everything else looks right to me. Any other questions about that? Okay. How are you guys feeling about the transistor stuff?
Pretty confused.
Pretty confused?
Yeah.
Okay, well, let's do another one and let's just think through it. I mean, so let me start by, let's forget about the breadboard for a second. So let's say that we want a circuit that powers a device that's not a motor, so we'll forget about the diode for now. When output pin 7 is high. So in your program, when you say, make output pin 7 high, we want that motor, the device to turn on, whatever the device is. So we have a transistor. And we have an Arduino. And all we care about here is the ground pin and pin 7 that in the program we would have set to output. And then we have a 10,000 ohm resistor or 1000. Either one of those actually works. 1000 is fine though. You have more 1000s. And then we have just the battery that powers the device. And the device and let's say that this device has a positive and negative terminal like that. Okay, so I'm going to go. So the idea is that I'm going to erase this in a second, but so if we hook that thing up like that, that's the device running. Okay, and that's all we need to do. But we need to put the transistor in there in a way that the Arduino decides when this is connected and when it's not connected. So I'm going to go from the output pin 7 to the resistor and to the base of the transistor. And then I'm going to go from the emitter of the transistor. I'm just trying to make it so wires don't have to cross in this picture. So I'm going to go all the way around like that. Okay, so the way it's set up right now, when you program pin 7 to be high, it allows current to flow in the collector and out the emitter. Okay, so, and now we're going to go so now we're going to go from the positive of the battery to the positive of the device. And now I'm going to wire this device into the transistor. So this is going to go to the collector. Okay. And then that current has to flow somewhere. We want it to flow to the negative terminal of the battery. But for this to work, we need the electric potential of the negative of the battery to match the electric potential of the ground. So I'm just going to take this and connect it here somehow. Anybody have any questions about that? And so then now let's think about how we would do this with a breadboard. So essentially, we're going to use the breadboard to make all these wire connections. You could do this all with alligator clips and stuff. It would just get really messy and it would fall apart really easily, you know? So when you're trying to get it out of your car back to the whatever, you know, it just wouldn't stay together. It would get really big and bulky and ugly. It would be easy for the wires to touch each other and mess up the flow. So the breadboard makes it kind of possible to do this. I'm going to, let's see, I'll put a breadboard in the middle here. I'm just going to do it as, instead of lines like this, I'm just going to, or instead of dots like that, I'm just going to draw lines. And so we'll say any of the holes in any of these lines are connected. Okay, so that's the breadboard. And we have the Arduino with the ground and output pin 7. We have the 1000 ohm resistor. We have the transistor. And then we have the battery to power the device and the device. Okay, so I'm going to go from pin 7 of the Arduino to the breadboard. And then I'm going to go from that line of the breadboard to the resistor. And I need 3 places on this breadboard to represent the transistor. You actually wouldn't use wires here. You just plug the transistor right into the spots on the breadboard. But there's the transistor. And now I'm going to go from the emitter of the transistor to the ground. And now I'll go, so now the transistor is all in place. That pin 7 is determining whether there's a connection between the collector and emitter or whether there's not, based on how you program it. And now I'm going to go positive of the battery to positive of the device. Negative of the device is going to go through the collector. And then the negative of the battery is going to connect to the ground.
It's the left side of the transmitter.
The far left prong of that transistor
Yeah.
is that's the base. So you can think of that as that controls whether the thing closes the circuit or not. So when you program there to be it's actually not voltage, it's a small current. But when you program to be a small current that goes in the base and out the emitter, that connects a current, allows a current to flow from the collector through the emitter. Yep.
Should there then be a line from the left side of the resistor to the base?
God dang it. Yes. So the left side to the, yes. That's, why doesn't my circuit work? This is, and actually, like, most likely you'll have things like that, and you'll be staring at it, and your thing won't work, and you'll be convinced your transistor is broken or something, and it's something like that. Okay, so that really messed up the nice Van Gogh style flow I had going. So now it goes, it's probably always good to recheck. So we have this going into the resistor, out here to the base, right? Yes. And then that current can flow from the base through the transistor, out of the emitter, and that goes to the ground. So the transistor is set up right. And then this thing, we have from battery through the device, and then before the circuit is closed for the device to make it run, we're forcing it to go through the collector and then out the emitter, and then it goes to the negative. And that negative, a key step is that negative of the battery and the ground of the board have to be the same. So you have to connect those two with the wire. Because if you didn't have those two the same, you wouldn't have so if you didn't have those two the same, then well, for this thing to run, you need a difference in electric potential between the positive and the minus. But in order to get current to flow through the collector and the emitter, you know, that emitter has to be the same, like negative terminal, basically the same ground as the board does. And so you need to match those two up for both of those two. I mean, to me, it's kind of like two separate circuits, you know, but you need their negatives to agree, you know, in order for them both to use that same transistor.
Okay. So we know the transistor output and the battery all need to share a ground.
Yeah. Any other questions about that? Okay, well, so let's say that this is a motor now, because the thing we're going to use is a motor in this demonstration. So I'm going to erase this, and I'm going to say it powers a motor. And so we are going to want to use a diode. So let's see where this diode fits in. Well, we want the back, the feathers side of the arrow to connect to the negative of the battery. The negative of the motor. Let me just make this a motor. So M for motor. And so the negative of the motor is here. Is that right? Negative.
That's the ground, right?
Here. And then, well, I don't have, well, let me adjust this so it goes,
Which one do you guys? No, we don't really have any. Do you have any other ones now?
so we'll do this.
It was the block. There was a flower that
And this.
motion sensor, and then the string. Yeah, pointing to the battery. I think the yeah.
So getting that diode in there makes it look a little uglier, but
The diode connects to both positive ends of the battery and the motor.
it just really all we want is for it to connect to the positive and negative of the motor. But you know, the positive of the battery is connected to the positive of the motor.
Positive and negative.
Yeah. It just allows this backward current somewhere to go instead of the transistor, or instead of the Arduino.